So instead of buying the point salad game, I bought a microphone for myself. Okay, so does someone have which one of these is the right answer? Oh, -1 works. How do you figure out -1 works? Oh yeah, you just plug it in. Let's see, -1 squared is 1, plus 2 times -1, that's -2. 1 minus -1, that works. And this one doesn't work, you say? Oh yeah, that's 8 on the left side, and on the right, yeah, that's definitely not right. Okay, so when all's said and done, this one is no, this one is a yes. Very good. We're going to do the same thing, but with differential equations. So let me find the first example here. Skip that, get to this. There we are. There. All right, this is fun. So we can do exactly the same thing, except we're going to, instead of plugging in a number, you're going to be plugging in a function. But you can handle this, I'm pretty sure. So let me guide you through this one, and then I've got another one for you to do. So for this one, I'm going to plug in the function tangent of t for x. Well, that's easy enough to see that I'm going to put tangent of t in here. So that's going to become tangent of t, but I need to figure out what goes here for dx over dt. So let's go ahead and do this, dx over dt. And let me find, I know everyone knows the answer to this, but we'll just pick someone at random. It's much more fun, isn't it? Joshua, do you know the derivative of tangent of t? Very nice. Good job. Secant squared. You pulled it out. Good job. So the derivative of tangent is secant squared. So now, just like with the problem where you're plugging numbers into a regular algebra equation, we're going to do the same thing here, but we're going to plug functions into this. So this thing becomes this, secant squared of t. That's the left-hand side, the dx over dt, and that is going to equal tangent squared of t plus 1. I guess it's not true. No, I'm just kidding. You know it's true, right? So you might be looking at that saying, that looks familiar. It is familiar because sometime, maybe it was not so long ago, you learned that these are equal to one another. This is one of the trig identities referred to as the Pythagorean identities. So you're probably more familiar with sine squared plus cosine squared is equal to 1. This is related to that. If you take sine squared plus cosine squared equals 1, divide everything by cosine squared, you get this. But this is true. So this one's true. So that means that this is a yes. Yes. So exciting. All right, so I've got a few of these for you to try. So let's try this one. So here are two separate, and this is going to be a little bit more tedious, but you can do it. So these, you're going to do both of the one at a time here. Yeah, one, then the other one. But if you do the first one, just so you know, if you do that derivative, then the second one should be relatively easy to do. So do the first one. You can work with a friend if you need to. Oh, and I'll even write down what your first move is to do this. If that helps. I'll give you a couple of minutes. Ooh. All right, we're going to see. I see that you're really deeply engaged in conversation, so I hate to cut it off, but we do need to move on. So let's go ahead and see how we're doing. Rachel J, what's the derivative of sine of 8t? Nice, 8 cosine of 8t. So this is, like I said, this is a bit tedious to work through, so that's why I'm going to break it up into little bits. So you've already done something. Madison, what about the derivative of 2 cosine of 8t? Nice. Sine of 8t. I've got my plus minus there. It's actually the negative. You're right. Here, I'll put parentheses. How about that? Okay, very good. So we've got the derivative. Now what we need to do is take that derivative and shove it up there and see if it's correct. So I suppose I don't really need to rewrite that, do I? I could just write down what this equals. So maybe I'll do that right here. 4y, that's supposed to be a big comma. That's making it worse, aren't I? Whatever. But 4y minus 20 sine of 8t, I'll put that right here. This is the bad part, is 4 times sine of 8t plus 2 cosine of 8t minus 20 sine of 8t. Oh, it's a lot to sort out. Well, let's do it. So I've got 4 times the sine of 8t is, well, 4 sine of 8t. And then 8 cosine of 8t minus 20 sine of 8t. Wait a minute. If we combine these two, we get negative 16 sine of 8t, don't we? Doesn't this balance? It works. Oh, come on, it's more exciting than that. You should be happy. Yes. Okay, so that works out. Now, here's an interesting thing about the next line. You might say, well, that is the solution. Well, it isn't. It is a solution, and there are more than one solution possibly. And in order to save you a little bit of time, let me just point out that we've pretty much done, I should have done this on Notability, then I could have copied and pasted. We've done all the work we need to with the sine of 8t and the cosine of 8t. We've shown that all of that balances out. So what happens with the e to the 4t? That's all that we really care about. So when we throw the e to the 4t in, does that change? Like, what does that change in terms of that differential equation? Yeah, I regret not doing this on Notability now because you just stick it in there, slot it right in. Well, it's okay. Let's go ahead and do the derivative and see how that works. Austin, what is the derivative of e to the 4t? Yeah, 4e to the 4t. And here's what I'm going to do because I'm lazy, is I'm going to just do this plus a bunch of green stuff. There we go. But we know what that hard to read green stuff is. It's this stuff right here. So that stuff we've already done. Okay, now let's plug this in up here. So that's that. Now what happens to the left-hand side of this? So here's what I'll do. Let's see, put this in blue again. So 4y, so I'll put a comma. I'll try to do a better job. That's a little bit more like a comma. 4 times y minus 20 sine of 8t. That equals 4 times e to the 4t plus a bunch of stuff. Whoops, come on. Why is it not doing it? There we go. There we go. Now, what we did up here is we found that all of this stuff is the same as all of this stuff, right? We already did the math. I don't want to have to do the math again, but we could do it. It's going to look exactly the same. So that stuff and that stuff are exactly the same. So the green stuff is the same. What about the blue stuff? It is the same. It's exactly the same. And so here we have two very different functions. I don't know if you think of them as very different, but I'd say that throwing this e to the 4t in makes it different. E to the 4t is an exponential, sorry, wrong direction, exponential function, grows without bound, whereas sine of 8t and cosine of 8t, they just go up and down, and they stay pretty, contained. They're bounded. So these are very different functions. They are both solutions to the same differential equation. One of the exciting things for this course is that eventually, actually not too long from now, in a couple of weeks, you'll take that and you will be able to solve that and be able to say, the solution to this is this. Right now, we're just checking to see if something is a solution. Okay, so let's try another one. So I have this differential equation, and I want to know which of these 4 functions is a solution, or which of them are solutions. There may be more than one. So here you have some things, and here's how I would suggest you go about this. Start with the simplest one, of course, and then work your way over, but you can reuse the work that you do, because notice that this one is just a combination of the first 2. And then this one is the first 2 plus an additional little nugget. So I'll give you a minute. You can work through this. I'm going to actually do this on Notability because that's going to be a lot easier. Freeze this. There we go. Won't it let me paste? So annoying. All right, sorry about the delay. I'm discovering every now and then something changes. You know how it is. Your app changes. They update Clash Royale and suddenly you can't play it anymore. Well, here, I don't know if it's an issue with user error or if it's the app has changed, but every now and then something like this happens and I can't figure out what's going. So I'll figure it out later, but today I've been having trouble pasting into Notability, which is annoying to me because I do it all the time, or I used to. Here we go, though. Okay, so let's see how we did. I guess in each of these cases, here, let's do it this way. I have A, y is equal to 2, y prime is equal to, I will fill in the blank, and then I will write down 4y minus 8t minus 6. Okay, so those are the things that I'm going to be working with. I've got the original function, y equals 2. I've got the derivative, dy over dt. I will do that derivative here, and then I will use the differential equation. I will plug y and t and see what I get. Okay, so let's find a volunteer. So Asol, what is the derivative of y for this one? Oh, just the 2 there. What's the derivative of 2? Yeah, so the first one here, the A. So derivative of a constant. Yeah, it's just going to be 0. I know, it's so easy, it makes it hard. So yeah, just 0. Very nice. And now what I'm going to do is I'm going to take this and plug it in over here and see what I get. Okay, so that's going to be 4 times 2 minus 8t minus 6. I think you can all guess what's going to happen, but let's do it anyway. So this is going to be 8 minus 8t minus 6, which is equal to 2 minus 8t. Sad. The reason I'm sad is because this does not match this. Whoops, I did too much there. Just a minute. It does not match that. Okay. So for our differential equation to be correct, for it to be a solution, then the left-hand side derivative should equal the right-hand side. All of this stuff after you plug in the function and everything. Okay, let's do the same thing for the next one, letter B. Y is equal to 2t, y prime, and then I'll do 4y minus 8t minus 6. Okay, let's find a volunteer. We got it. Luke, what's the derivative of 2t? Just 2, very nice. Now we'll plug this. This is all that gets plugged in over here, isn't it? So I'll plug that in over there, and I get 4 times 2t minus 8t minus 6. And that's going to be 8t minus 8t minus 6, which is equal to negative 6. That's not the same either. So when I compare these two, on the left I've got, when I say on the left, I mean the left-hand side of that differential equation. I have derivative equals to 2. On the right, when I plug in everything, whoops, it's getting a different color, I get negative 6. What that represents is what you get when you plug in stuff into that side. Those are not the same. So sad. We have a frowny face. No. So this is a no. This is a no. All right, I mean, sad, but maybe we can find something here in a minute. Okay, what about y equals 2t plus 2? 4y minus 8t minus 6. Okay, next volunteer. We need a derivative. And Cooper Stiegel, what do you got for your derivative? Wasn't that the derivative of the previous one? Oh, they're just the same derivative? Okay, I believe you. Okay, so now we're going to plug this in. So plug this in for y to see what we get. So let's see, this is 4 times 2t plus 2 minus 8t minus 6. So this will be 8t plus 8 minus 8t minus 6, which is going to equal 2. Wait a minute. In this case, the left side of that differential equation and the right side of that differential equation are the same. And so this is a happy one. This is a yes. Because this one, so going back just to show you the differential equation that we're trying to work with, the derivative, which in this one was 2, is the same as when we get done simplifying the right-hand side, we also got 2. All right, I know, it's not that exciting, isn't it? But it's exciting to me. Okay, one more, letter D. Let's do letter D. Y is equal to 2t plus 2 plus, let's see, can't we just, you know what, we can. Here's what I'll do. I'm just going to do this, copy, paste. I suppose I may have jumped the gun here, so let's just do this. We don't know if it's a yes or no, and we don't know if we're happy. Okay, so let's fix this because it's not, this last one is not 2t plus 2, it's 2t plus 2 plus 2e to the 4t plus 2e to the 4t. So I need to add something to my derivative. So I need the derivative of 2e to the 4t. Claire, what do you have for the derivative of 2e to the 4t? Very nice, 8e to the 4t. And let's see, where does that go? I guess that would get stuck in here so that here, let's see, I can move this over. Give me a sec. I just shift that over a little bit. Here, I will highlight what I'm doing once I get done. So plus 2e to the 4t, is that where it goes? So that is this right there. So that's the only difference between the previous problem and this one. And then that will result in 4 times 2e to the 4t, which is 8e to the 4t. 8e to the 4t. And sure enough, that's the same. This and this are the same, which means that this thing makes us happy. And sure enough, whoops, this is a solution. So this is also a yes. So yes, yes, 2 no's, 2 yeses. All right, let me back off because some of you are confused and have no idea what we just did. So I want to make sure that you figure it out, or if you have questions, I mean, we can do another one of these, but I want to make sure that this isn't, you're not losing your mind at this point. Oh, no one's lost their mind? Or maybe it's gone and there's no bringing it back. Okay. Hopefully that's not the case, but let's switch back. Whoa, switch back to here. Okay, so whoops, it's okay. It's just T. Let's see. So there we go. I'll give you that one. Yeah, I'll clean this up in just a second. Let's see. Which one do we care about? Let's. Well, I don't know. Here, just do a few. Let's do this. Let's try this one. Oh, can you see? Can you see it? Yeah, you can see it. You're not. Yeah, let's do this one. Do this one. Sorry, I'm nervous about my T. So do that one and do this one. So do these two. Try those. So do letter B first. B is pretty easy, and I'll clean up my mess. I have no sugar in my tea, so there's not going to be sticky. Just going to humidify. Yeah. Oh, interesting. No, it's supposed to be x of t. Yeah, good point. Sorry about that. I mixed my dependent variables, didn't I? These should be x of t. X of t, sorry. Those are all x's. Just make them into x's. There. Let's see. Let's do this. There we go. Okay. Some volunteers. All right, it looks like I'm going to need if I'm going to check this particular differential equation, I need the third derivative, second and first derivatives, but I'll need the third derivative. So let's go ahead and get this. Matthew, what is the first derivative of this function letter b? It is 1. Very good. Very good. 1. All right, while you're on a roll here, Matthew, what about the second derivative? Really? Just 0? And what about third? Oh, yeah, it's just 0. Well, that's kind of boring. Well, it makes our calculations a lot easier, doesn't it? So let's go ahead and see if this is a correct equation. So now I'll take those along with the original function and shove them into this differential equation, the one up top. So let's see if I can do that. 2 times 0 minus 3 times 0. So I'm just copying the differential equation down and putting the derivatives in. Minus 59 times 1 plus 30 times 2 plus t. And we want to know, does that equal 30t plus 1? So here I've just copied down the whole thing, and I've put the function and its derivatives into the left-hand side of this differential equation. On the right-hand side, I just copied down that thing there. And then we're just going to see, are they the same? You probably have done this before when you used to check algebraic expressions. So it's a similar thing that we're going to do. Okay, so let's see if these are equal. I guess I have negative 59 plus 60 plus 30t. Ooh, that does equal 30t plus 1, doesn't it? So that is yeah, this is a yes. So does that work out? Looks good. All right, now let's throw in this additional exponential, but we've done a lot of the work. Notice that we've done this, we've done this. I think we could probably stick it in there. If I'd left a little bit more room, we probably could have stuck it in pretty easily. I'll move some things around, but I'm gonna now, let's get rid of this arrow, and we'll put a new arrow there from here. We'll do letter C. So Matthew's already given us the derivative, second derivative, and third derivative of this thing. Zechariah, what's the additional term that I'm going to need because of this e to the 6t? What's the derivative of e to the 6t? All right. What about the second derivative? Ooh, I think I see a pattern here. What about the third? Do you know the third derivative? Very nice. Okay, so it looks to me like really all we have to do is just put some additional stuff into the left-hand side of this stuff down here and see if everything comes out nicely. So let's do that. So here I'm just gonna move through the magic of the computer, I guess. Let's see, we'll get rid of that. Let's move this. Give me a sec here. And I will change colors as well so that you know what I've changed. There we go. Okay, so the new stuff is going to be this 216 e to the 6t in there. This is going to be 36 e to the 6t. And this will be 1 plus 6 e to the 6t. And this will have plus e to the 6t there. Sorry, it's still a little bit of a mess, I guess. But really, that's the additional stuff in the green looks almost the same color as black, probably, for some of you. Sorry about that. So what we're going to do now is just collect up. We've done all of the 59 is here. Here's the 60. Here's the 30t. So let's just check the rest of this. Let's deal with this, the e to the 6t's. So 2 times 216 is 432. E to the 6t minus 3 times 36 is 108. E to the 6t. And then this is 59 times 6. Just a minute. That's going to be 360 minus 6, 354. E to the 6t. It's supposed to be a 6 there. And then I've got this last one, which is plus 30. E to the 6t. Okay, let me just double check. Did I collect all the terms correctly? 30. 59 times 6, if I'm right about that. I think that's right. Because 60 times 6 is 360, so that should be right. 3 times 36 is 108, and then 2 times 216 is 432. Now I feel good about this. Okay, so now what I'll do is I'll just collect them all together, add all this up. 432 minus 108 minus 354 plus 30. I get 0. Do you get 0? Okay, so we got 0. So this is, yeah, it's true. It's still true. So I'll put another check there. That one's also true. So this is a yes. Interestingly, I'm pretty sure that this next one also works. So this would also be a solution. Now you might wonder, how could you have so many different solutions to a differential equation? And the reason is that when you have a differential equation that is a first order differential equation, generally there is one sort of one building block that all solutions look like. Let me just show you an example of this. So if we have this, y prime is equal to y. Nice, easy differential equation. You know the solution to this. The function whose derivative is the function itself is e to the t, or e to the x. But that's not the only solution to this. I could do this, 2e to the t, or 3e to the t. Any constant times e to the t will be a solution to that. And every solution to this will look like this. So that's first order. Second order, on the other hand, let me just show you an example of a second order differential equation. I'll try to make it easy. Second order, here we'll do d squared y over dt squared plus 3 dy over dt plus 2y. Sorry, I don't like this one. I'm going to make it negative. Okay, that's better. Yeah, that one works. Equals 0. So let's start with this pretty easy differential equation. You will learn how to solve this. It's so easy that I can solve it right now and tell you what the solution is. But let me just tell you this, that one solution to this, and you can verify this later if you want to, one solution is e to the 2t. Another solution, a pretty easy solution, is y equals e to the t. And you'll notice that e to the 2t, even though it looks sort of like e to the t, these are different functions. So those are the two second order differential equations. You have two of these fundamental solutions, these basic building blocks. Every other solution will be some combination of those two. So when we go up here to this is a third order differential equation. Third order because third derivative. And so we should expect that there are three separate building blocks that you could put together to make all the different solutions to that differential equation. And we won't get into all of them, but one of them is e to the 6t. One of them is e to the negative 5t. And I don't know what the third one is. I'm going to guess e to the, I don't know. Yeah, I can't tell but just by looking at it. But you can be assured that there is another solution. E to the t over 2, maybe? Anyway, so that's one of the jobs is that we're going to have this semester, is to learn how to do that, how to figure out what the solutions are, what the building blocks are, and put them together to make solutions to actual real life problems. Okay, so let's get back here and see what we have. Okay, whatever. done that. Okay, so here's so when we talk about these particular these building block solutions, you have a family of solutions, and you can see that this particular family of solutions for this differential equation, the building blocks are e to the x and x e to the x. Now, before we go on, let's verify that this family of solutions is the correct family of solutions for this differential equation. To do that, I'm going to need to do what I just did, but with the C's, C1 and C2, which is annoying, but I think we can overcome this. We can do this. So I need to do the derivative and the second derivative of this function right here. Max, you know what the first derivative is, right? You can do it on the fly. I have confidence. Yeah, using the product rule, right? Yeah, C2 e to the x, very good. So yeah, that's the issue with this one, is you have to use the product rule over here, which is annoying, but we can overcome it. Max, you did a brilliant job there. So let's do the second derivative now. Now that we've got the first derivative out of the way, the second derivative shouldn't be too bad. Cooper C, what do you got for your second derivative for this thing? C2 e to the x, very good. So if you're wondering where Cooper got all of this stuff, I'll just highlight the fact that this thing, using the product rule, turned into those two things. And then the derivative of C2 e to the x is just C2 e to the x. And so that's where everything came from. So you could certainly combine those last two terms into a single term. Okay, so now we have to verify. And by the way, your homework, you're going to have to do stuff like this. It's a bit of a pain. And so there's a lot of bookkeeping, if you will, trying to keep track of all the different terms. But you can do this. It's going to be okay. So here's what I'm going to do is down here, down at the bottom, I'm going to write down as best I can. I'm going to collect all the like terms for the left-hand side of this. Now, I'm going to do this here. Maybe I should write it down. Y double prime minus 2y prime plus y. So I'm going to do this sort of in a relatively efficient way, if it's okay with you. So what I'll do is I will first deal with the C1 stuff. Notice that you have C1 e to the x in each one of these. So let's just put all of those down. So you have y double prime, which is C1 e to the x, 2 times y prime, C1 e to the x, and then y, which is just C1 e to the x. So you could have written down all of this, then 2 times all of this, then all of this. And then collected like terms after doing that. I'm just collecting them ahead of time, I guess. So that's the C1 stuff. And you'll notice that all of that is 0, isn't it? It all cancels. So that's all 0. Now let's deal with, how about, let's do the x times e to the x, C2x e to the x stuff. So you've got one here, you got one here, and you've got, I think, just one. Is that right in the initial? Yeah. So there's this here. Maybe I'll change colors even. Change to, oh, the green is terrible. How about orange? So use this one, and this one. So let's collect all those. Once again, if you're more comfortable doing this, writing out every single line, it's fine. I'm kind of skipping something here, but so we have C2x e to the x minus 2 times C2x e to the x plus C2 e to the x e to the x. And there, those things all combine as well. There's one of them here, negative 2 of them here, and then another one. They all get their 0 as well. And then the last thing we have to worry about is this C2 e to the x. I guess I'll do that in red. You'll notice that for y, there are 0 of these. For y prime, there is 1 of them. And for y double prime, there are 2 of them. So the way this is going to look is this. I have y double prime, 2 of these, minus 2 times y prime, plus y, which there's 0 of them. So here we have 0 of this, we have 0 of this, and we have 0 of the first one. And so the final answer is 0, which checks out. Isn't that beautiful? Now, here's the interesting thing about this, is that if you were to graph different solutions to this, here's what the various solutions would look like. And these are for different numbers. If you plug C1 equals 1 and C2 equals 1, if you have both of them equal to 1, you're going to get something similar to this green curve here. If you let C1 equal 1 and C2 equal -1, you're going to get something more like this blue curve here. So depending on what numbers you choose for C1 and C2, you'll get a different solution. But they're all in the same family. They all look like this. So when we go to solve actual problems, we're going to be looking for which of those solutions matches our data. And that's how we'll decide which one is the correct one to do. So there's that. Let's see, this one. No, just a minute. I thought I had something else. Give me a sec. Because we only have a few. We've got 10 minutes left. Oh, this one's kind of fun. Yeah, this one's fun. Yeah, solve this. This one's fun. This one's easy. You can solve this differential equation yourselves because this is a calculus 1 problem. In other words, I just want to know the antiderivative of this. So go ahead, solve that differential equation. All right, let's see how we're doing. Mariah, do you have a solution to this? Just a minute. Y is equal to sine of 2t plus c. All right, that's the family of solutions for this differential equation. I know we didn't think of that as a differential equation back in Calc 1, but that is a family of solutions for this equation. Every function that looks like this will have a derivative that looks like this. Now, if you graph those derivatives, that is, if you pick different numbers for c, I think we could all figure out what that looks like, right? Let me show you. Here's what the graphs look like. So if c equals 0, you get this blue curve. If c equals negative, I don't know what negative that is, -1 and it must be -1 or -2, whatever. Anyway, depending upon what value you have in here for c, you get a different sine curve. They go up and down. So you're sort of familiar with this idea already of having a family of solutions. Okay, let me just show you another one of these. And that's this one. So this is the one that we had just a bit ago. This one I'm not going to make you solve, but I can write down the solution to this. If I have a little bit of help, I need to go back to my previous slide. I don't know where it is. I'm going to have to go to Notability. Here we go. I know what I can do. Split view this with Notability. Oh, interesting. You can't see Notability. All you can, so I could have my notes over here. That's fascinating. Okay, see, I learned something new. Let me go back. I'm just going back to the solution that we had. Where is that solution? Oh, I didn't do it in Notability, darn. Okay, I guess I have to go back here. Give me a sec. There it is. Okay, so e to the 4t sine and 2 times cosine. Okay, so where did my solutions go? There it is. Okay, so here is the general solution. The family of solutions looks something like this. C e to the 4t plus sine of 8t plus 2 times cosine of 8t. So that's what every solution to this differential equation looks like that. And so here you'll notice that unlike with your constant of integration, the constant of integration is all by itself, and the family of solutions just looks like the same curve going up and down. With differential equations, you end up with this family of solutions where the constant isn't all by itself. It's multiplied usually by a function. And so if you graph this, pick a bunch of different numbers for C, here's the different solutions that you end up with. So you have the general, if you have C equals 0, that's this blue curve here. But if you let C equal 1, you can imagine what's going to happen is that when the values of t get above 0, then this thing will start to dominate the graph, and you start increasing and increasing quite quickly. And if c equals something like -1, it's a similar situation, except for when the function, when t gets above 0 again, suddenly that starts to become important, and you end up becoming very negative because of that negative e to the 4t. So, but this is the sort of thing that we're going to hopefully become more familiar with, is this idea that you have families of solutions that, that you'll be dealing with. Okay, so on your homework, let me just review just so that, because it's still confusing to me just as with to you. Let's see, is this, no, that's not, that's something else. Here we go. That's not your class. Here's your class. That pink blob is going to go away next week, supposedly. I can't wait. Okay, so down here, if you click on homework, you'll find the list, and the list has only one thing on it, but I will probably add more to it. But just be assured, even if this ends up having 10 things on it, the only thing you have to do for Wednesday is this. So numbers 1 through 7, 9 through 12, 22, and 23 on the first homework section. So if there are other questions, stick around and we will talk, but you should be able to find this in your textbook. If you don't have the textbook yet, make friends with someone who does. Oh, and please do this as a group, like work with a friend when you're doing your homework. It's the best way to do your homework.